Hi everyone, this is our group member. First, Ahmad Akifuddin bin Tajurus. The matrix number is 2023677928. The second one is Muhammad Haziq Hilmi bin Cik Alwi. The matrix number is 2023667702. And lastly is me, Muhammad Haikal Haziq bin Kamaruzaman. The matrix number is 2023628752. Now, let's move to the table of content. First, we will start with an introduction to the topic. Second, we will look at the characteristic of queuing system. Third, we will explain the queuing model used. The fourth one is we will discuss the waiting line characteristics, and finally we will wrap up with a conclusion. Now I will explain the introduction of our study. The observation was conducted at a commercial center located in Cabang 3, Kuala Terengganu. This place operation with 2 servers and it's open from 9 AM until 10 PM. Our observation was carried out from 12 PM until 1 PM, which is considered a peak hour with a higher number of customers. Now, let's move on to section 2.0, characteristic of queuing system, specifically focus on 2.1, arrival characteristics. There are 3 main elements we need to understand. The first one is the size of the calling population. In this system, the population is infinity. This means the number of potential eco customer is seeking service is so large that it is considered unlimited. The second one is the pattern of arrival at the system. Based on our data, the arrival rate is 28 customer per hour. And lastly, the behavior of the arrivals exits. We categorize the arrival here as patient. This means the customer will wait in line calmly until it is their turn to be served, without leaving the queue permanently. Now, let's look at section 2.2, waiting line characteristic. There are 2 main points to discuss here. First, the length of line. In this system, the length is unlimited. This means there is no maximum limit to the number of customers that can wait in the queue. Therefore, eco customer can continue to join the queue even if it becomes very longer. The second one is the queue discipline. The system follows a first in, first out FIFO rule. This means that the eco customer that arrive first at the payment counter are the first one to be served. Now for section 2.3, service facility characteristic. First, the number of channel. We have a multi-channel system where S equal to 2. Second, the number of page. This is a single page system, meaning there is only one station for service. Lastly, the number waiting lines. This system uses multiple lines.
So here are the data for the counter 1 and counter 2 at the eco shop. So we calculate the average arrival rate, that is lambda. The total customer is equals to 28 and the observation period is equals to 1 hour. So the lambda is equal to 28 customer per hour. So next is average service rate at each channel, that is mu. Server A and server B, there are 40 customers each server. So the service time per server, there are 5 customers that are 3 minutes service time equals to 50 minutes, and 9 customers that are 2 minutes service time equals to 80 minutes. So the total service time per server, 15 plus 18 equals to 33 minutes. So average service time equals to 33 over 14 equals to 2.36 minutes per customer. So average service rate per channel, mu equals to 60 over 2.36. Mu is equals to 25.4 customer per hour per channel. So next is traffic intensity. The formula is lambda over server times mu. So the traffic intensity is equals to 28 over 2 times 25.4, that is 0.5512. The probability that the system is empty, the formula is 1 over 0 factorial times 28 per 25.4 square plus 1 over 1 factorial times 28 per 25.4 the power of 1 times 1 over 3 factorial times 28 over 25.4 cubes times 1 over 1 minus 0.5512. That is, the answer is 0.3552. So the average number of customers in the queue, there is 0.5512 times 28 over 24.5 square times 0.3552 over 2 factorial times 1 over 1 minus 0.5512 square. So the average number of customer in the queue is 0.59. The average number of customer in the system, L is equals to 0.59 plus 28 over 25.4, and average number of customer in the system is 1.69. So the average waiting time in the system, W is equals to 1.69 over 28, so we get 0.0604. So we times with 60 and we get 3.62. Next, the average waiting time in queue, WQ equals to 0.59 over 28, so we get 0.0211, and we times with 60 and we get 1.26. So the queue model result for the system with 2 service counter. Based on the analysis, the average server utilization is about 56%, which show that the counter are not overloaded. The average number of customer waiting in the queue is low, and the average waiting time in the queue is approximately 1 minute, indicate that the customer don't experience long delay. The table of probability show that the most of the time only a small number of customers are in the system, which means congestion rarely occur. The sensitivity analysis also show that increasing the number of servers reduce waiting time and queue length, but the improvement becomes smaller after 2 servers. Therefore, having 2 servers is adequate, as it provides efficient service while avoiding unnecessary additional costs.
So now let's move on to the waiting line characteristic. So this is the multi-channel single-phase system. Okay, now as you can see, there are 4 types of waiting line characteristic, which is arrival, waiting line, service facility, and operating. So for the first one, which is arrival, customer arrivals are frequent and unpredictable, especially during peak hours. After that, which is waiting line, the waiting line system is simple, organized, and suitable for a retail environment. After that, service facility. The service facility is efficient and well balanced between the 2 counters. And last but not least, the operating. The EcoShop checkout system operates efficiently, and the number of service counters is adequate to meet customers' demand. Okay, now let's move on to the last part from this video presentation, which is the conclusion. So first, the number of servers is adequate if queues are short and customers are served smoothly. If waiting time is long, more servers are needed. After that, customers are happy if the waiting time is short. Long waiting times will make customers unhappy. From this project, I learned how to apply what I studied to a real situation. I understand how the number of servers and service time affect customer waiting time. I also learned how to observe results, analyze them, and make simple conclusions. Overall, the project improved my understanding and problem-solving skills. I think that is all from us. Thank you for watching this video presentation.